This video, I'm going over the main ideas from section 2.2, which was uniform density curves. There's not a lot that I feel like I need to go over, so I just wanted to review the vocab and then maybe remind you of some formulas that you'll use in the assignments, potentially, depending on if you get these problems. So remember that a density curve is something that is above the horizontal axis, and that the area between the curve and the horizontal axis equals 1 square unit. And so you'll see problems where it'll give you like a density curve that looks like this. And so the fact that this density curve is both above and below, or this curve is both above and below the x-axis, this is not a density curve, okay? So it has to all be above that horizontal or x-axis in order for it to be considered. So that's the easy one. The harder one is when you're checking to make sure that the area is 1 unit. So most of them will be rectangles, so you're checking the height, the length times the width. Or the base times the height, however you want to think about that. And so that's the formulas that they used within the problem. They also did like a triangle. Remember, that's 1/2 of the base times the height. And so those are the more standard formulas that you'll see. But I did want to remind you of the trapezoid area formula and the semicircle area formula, because you will see, or you can see those in the problems. So remember that when you have a trapezoid, you're essentially finding the average of the two bases. So for this one, they're calling it A and B. So you're finding the average of those, adding them together, dividing by 2, and then multiplying it by the height. Okay, so you need to do that to find the area of a trapezoid to check to see if it's 1. And then the area of a semicircle is half the area of a circle. So you're going to be given a radius, right? So you're going to take the radius value, square it, multiply that by pi, and divide by 2. And then that, if that equals 1, then you have a density curve. Okay, so I just wanted to remind you of those formulas just in case you needed them, because they are in some of the questions. And then lastly, we've got a uniform density curve. One thing that I wanted you to remember is that in a uniform density curve, the mean is equal to the median. It works like a symmetric distribution. So if I think about it, when it's uniform, I meant to change. When it's uniform, it is a perfectly horizontal line that's parallel to the x-axis. And so you can think about that as symmetric, right? If I were to cut it in half, then I would have equal parts on either side. And so in that case, what's happening here is that this value, whatever this is, this should be the mean and the median. The same way that if I have a symmetric data, my curve looks bell-shaped, let's say, then the mean and the median are at that peak. Okay, so that's all that I felt that I needed to go over for 2.2. If you have more questions, remember you can schedule a Zoom session or just come into one of the regular ones, but hopefully you don't have any other questions.